Hello, I'm Drew Hogan. I'm a computer engineering student at Utah State University, and today I'm going to be talking about my senior project. So for my project, I created a homemade water jet cutter. Now I did this for the startup company called Tidy Tools LLC. The idea behind the company is a customer will organize the toolbox how they like it, and from that, a photo of that, they're able to create a DXF file. My project takes that file and creates these foam toolbox organizers. It cuts this out using the high pressure water. Now how I do that is I take those DXF files, they're inputted into a STM32 Linux computer. This computer handles all user interface through a monitor and keyboard, and I also parses through that file to create basically a 2D array of structs, each struct containing the coordinate points of the points that go around the edge of all these tools. Now that data is sent to the microcontroller, which then goes through those points, controlling the motors to the gantry and turning the pressure washer on and off accordingly. Here's the whole project. Right here fits on this table. We have a monitor for the user interface, and all the electronics are in here. I'll go over that in a minute. And then the CNC machine, which we've attached our nozzle here. 0-degree pressure washer nozzle did the trick, and some homemade 3D printed clamps, some limit switches for all the axes for when it resets. And this is a homemade box here. You can put a foam right in there. 2 zip ties do the trick to hold it in place while the machine is running. And then a nice place right here to hook up a hose so the water drains. And this is about where we want the water level. So that is just an open drain, and then there's a plug when you're all done and you want to wrap up a session and drain out all the water. So taking a closer look here at the electrical box, We have our 36-volt power supply to supply power to our servo motors and our stepper motor. All the motors are servo motors except for the Z-axis motor here. And this is the driver for that stepper motor on the Z-axis. Whether it's this driver or the servo motors, they're all controlled the same way. There's a wire that controls the direction that the motor will turn, and there's another wire where I can send pulses. And I have them all configured so that 1,000 pulses is one rotation. One rotation of each motor is a centimeter of movement in the axis that we're talking about. So here's the microcontroller that controls all the logic here, and this is our solderable breadboard. A lot of the logic here is implemented to overcome the issue that these motors and this driver require at least 5 volts in as a signal, and they pull a lot of current too, more current than this microcontroller can supply. So our signals come here, they come through a logic level shifter. We have a 5-volt power supply that's tied right in here, and then to account for the sinking of current, we have transistors here. So then this can engage these transistors, which will tie us to ground in those instances, and we'll be able to send the pulse in the correct way. And then here we can engage the pressure washer manually if we like, and this is our limit switches here. So this is how the microcontroller identifies when the machine is in the home position, as it resets after every cut. And then under this microcontroller is the Linux board. Here is the pressure washer that supplies the pressurized water. I've taken it apart here, and there's a relay right in there that the microcontroller is able to engage and then therefore turn it on and off accordingly.